Alright, this is lab 10, and as we all know, we made some changes um, on the model. So now we gave you another model for the fan, and you do want to download this from web course. Okay, it's downloading. Anyway, so however, we already made some progress on this model, so you don't have to redo all of the work. Okay, so after you download this, you should open this zip and extract into the same folder. I have this one here. So next you want to open the same, and we can start working on this part. Once you get in the same, that's what we have done already for you. So we change a little bit on the position of the lower jaw as well as this locking, stopping block, whatever. Okay, and we put some hinges connection here and here. Um, now the 3D texture are all linear, so it will be over stiff, but that's what Dr. wants. And next step, we want to double click the fan. So now we are going to work on the fan. And here, actually, I have the slides open. Okay. Um, so what we want to do in this lab is pretty much finish the fan and the sim. Okay. So since we already have all the mesh, we only need one extra piece here for the pliers to squeeze. So we need to put a 1D C-bar between the jaws. Then we will finish the fan assembly. Uh, let's see, we need to put another pin connection here. Then we need to put some spiders between the handle and the stopping block. Okay, so next we will go into we're going to the sim and make the glue and the contact. Lastly, we will do the boundary condition and run the simulation. All right. So first, let's put a nylon C-bar here. So all the structure is basically steel, except this piece. All right. Now first, we need to insert a node in the middle of this two jaws, because we need. Let's have a look. Because we need something to apply a constraint. Okay. All right. Now, first we need to insert the node. So we're going to insert node between nodes. And here, actually, before that, we need to check. Um, if you remember, we made a reflection here. So this node is definitely on XY plane. And for this one in the center, okay, it's not necessarily on XY plane. So let's go to Edit, Node, and Modify Coordinates. So we can pick this one. Looks like this one is right in the middle. Okay, pick this one and check if the z is not 0, we need to change that, but looks like this one is fine. Okay, now next we will insert the node uh, between nodes, and we will pick this one and the one at the bottom, and there's our node. Apply. So now we can insert the C-bar for this nylon piece. Insert element and create C-bar. Okay, let's see what collector we have. Okay, we need a new collector for that. Okay, since we have different diameters, then from the top to the middle. Then the next session will be add to exist and mesh 3. Okay, mesh 3, and then from the middle to the bottom. That will be the nylon bar. Okay, and we can define the cross section in here, monkey wrench and monkey wrench. So the cross section. We need a new cross section. That will be a radius of 0.0625 inch. Okay, it's in the slides. So press OK and OK. Then the material, we will need to pick nylon. So nylon's here. OK. And there you go. That's the cross section. Alright, next slides. Okay, we have a couple connections here. So couple joints. We already put in those two, and you have to make this one and this number 2 ball joints between the gears. Okay, so it's pretty much the same as this one in terms of the handle and the lower jaw. So let's repeat this again. First, if you remember, we need to insert a node in the center of this circle. So let's go one slide up. So that's basically the structure. Okay, we have two coincident nodes in the middle. Okay. But let's start this first. We need polygon to insert to snap to the center of the circle. So insert node and create. Okay, that will be the center of this circle. Then we need one for the bottom. Apply. Now we have two for top and bottom. We need another one is right in the middle of these two. So let's use another command between nodes. So between the two nodes we just created. And if you remember, actually we need two nodes there. One for the spider of the handle, another one for the C-bar. So we can use apply and insert another node right on top of this one. So now here we have two nodes in the middle. Alright, next we will create spiders for the lower jaw first. So 1D connection, RBE2, where is that? Okay, it's here. Source is the center, then the target, we have a relatively easy method, related node. And for this one you have to turn on the polygon. So we will pick any related node to this polygon edge. Okay, that will be this one. It's on edge, and let's see which collector we want to put in. We can build a new one. Okay, you can even change the names here. Let's say lower jaw. Okay, then hit OK, apply. That's for this side, and let's go to the other side. Center node, target, related nodes, pick the edge. Okay, and apply. Alright, so that's two for the lower jaw. And let's turn off the lower jaw. And we can turn off all this 3D mesh, then turn on the handle, then turn off the other stuff. Okay, leave only the handle here. So we have two nodes here, remember? We only need to pick one. So just click once. The target would be related. Okay, if we're gonna use related, we need the 3D texture, the polygon, not the texture. Pick polygon face. That will be our target nodes, and we can put this in another collector, RBE2 handle. Click OK. So they do have, they share the same color and the thickness of this collector. Okay, the RBE2 collector. Alright, now we can turn this off. And once we turn this off, the node that belongs to the newly created spider will gone as well. It's hidden. So we only have one here. And let's turn off this handle. Then we do need the RBE2 for the lower jaw. So we need to put a C-bar between these three nodes, and it's welded. So let's insert element, create. Okay, C-bar, and we need a new collector. Alright, now from the top to the middle, then add to existing, from the middle to the bottom. Alright, so that's a C-bar, and this structure is welded, and however this RBE2 does not connected to is not connected to this structure now. So we can turn this off, and by the way, I like to change the thickness of the spiders on the lower jaw. Okay. Alright, and now we can insert the bushing. Okay, so if you look at this, the structure here plus a C bush, and through this C bush it will connect to the spider in the middle from the handle. Okay, now let's insert 1D connection, and by the way, you can use this icon, or you can use insert element, create 1D element, and the C bush. It's the same thing. The only difference is for this you don't have a source or target. You just pick two nodes. So let's try this method. It's still C bush, and this is still a pin connection, so we can put in the same collector. And you want to pick that node. It's not there, so let's turn on the node display. Okay, and try use the command element create 1D connection, C bush, pick this node. That's the first one. We need to pick the other one, which is in the middle here. Okay, and that is not good. I think I added this C bush into the old mesh we had, so that was yep. So now these two are the same mesh. That's not good. So let's just go back. Then go back. Alright, and let's make sure it's not there. Okay, it's not there, and let's turn on the node display, then insert element create. Okay, and here you want to create a new mesh, but under the same mesh collector. So let's try another way. We know there are two nodes in the middle. Right, if you look at this, we can simply just pick one and pick another one. And we do have a new bushing showing up. That's the one. To turn this off, you can see which one is which. Okay, and since they are under the same collector, they share the same physical property. So, like so, this one. Okay. All right. Next. So, by the way, these three are rotation on Z direction only. That's why if you look at the property here, we put a 0 on the Z rotation, but not like put a really big number on XYZ and XY rotation. That is 1e to the 8th. Okay. Alright, we're done for this connection. Then we will go to the ball joints between the handle and the stopping block. Turn off everything. Here, let's show this piece here. Okay, so remember this gear actually rotates on top of this stopping block. So what we do is we put another kind of joints here, but this time we're gonna free degree of freedom for 5 and 6. That's all 3 rotational degree of freedom. So anyway, let's first find a node right in between of this. So it's kind of hard. Let's try it. I don't know if I can just pick this. Okay. So specify a point right beside this, like between them, right in the middle, and make sure Z is 0. That's good enough. So you just click OK. And you have 1. Remember, we need 2 nodes for 2 different sides. Okay, you need 1 for the handle, you need another one for the stopping block. And lastly, you will tie those 2 up using a C bush. So insert another node right on top of this node. Okay, we have 2 there. Now we will insert a spider. RBE2 source. Just pick either one. Okay, let's pick the first one for the handle. Alright. And the source, the target will be 4 corners. If you look closely on this picture, we don't want related, I just want no method, so I can pick individual nodes. 1, 2, and let's turn this off too. Then 3 and 4. If you like, you can actually pick all the nodes here, so it might have a better distribution of stress. Okay, so still it belongs to the handle, so I'll put in this collector. See, apply. So that's the spider for this side, and let's turn this off. Okay, and turn off the handle, show the stopping block. See, that's the second node we created. Okay, and if you look at here, actually the target nodes are the 2 edges. So for the source, the same target, we have a fast way to pick it. Static wireframe, no method. Just box select every node on this corner and that corner. Then look at the side. Okay, and here it's RBE2 stopping block. So we need a new one. You can change the name right here. Okay, and just click OK. And then again, we're gonna change the thickness of the lines, maybe color. Okay, now we have 2 spiders that's not connected, and then we will create a C bush between them. So create element and C bush. Now we will create a ball joint C bush. So we need a new creation. We can change name here, C bush ball joint, or whatever name you like. Pick points. We can pick 2. Okay, click 1, click 2. Something flashed. So it's here. Okay, and edit display, we need to see the text. We also change the color of that text. apply. It's pretty small, but we can see that. Okay, and here we need to change the physical property. Okay, if it's none here, you can create a new property, or you can pick from whatever is there. Let's see. Okay, so the second one is not used. We can use e to the 8th. Control C for this one. Control V, Control V. You can leave this 3 blank. That's what we did in the model. So this is a ball joint. Okay, and next, I'm gonna do this right here. It's actually at the last, pretty late in the slides. You also want to define the coordinate system of the C-bush. By default, okay, they don't have a coordinate system, so you will have some warning if you run this. So you want to multi-select those bushing, right-click, edit mesh associated data. Okay, in here you want to enable coordinate system override, and the type it will be absolute. Okay, so now they have X, Y, and Z. That's kind of weird, but that's how they did it. Okay, alright, next is the pin size. Okay, let's show everything here, or just the pin. Okay, okay, we made this pin with this radius. But for this one, which comes with the model we provided, does not have a radius right now. So you want to find it, which is which power collector. Okay, this one. Right click, add it, and add it. You want to use rod 1. We just entered this. Rod 1 is actually the one we used for the nylon bar, and since they are the same, you can just pick this one up, and you can double check. Okay. You can get inside here, or you can just click information, and here you can see the rate, diameter 1, dimension 1 is this number. Okay, so that's good. And the material, it's not nylon, and we want to change that to steel. Okay, steel. And now you can see the shape of the pin. And let's do this for the next one. Okay, the bigger one. Okay, right click, monkey wrench, and now we need a new one. So create a new cross section. Radius will be 15625. Click OK and close. Material steel. Alright, now that's the size for the pins. Okay. Then next, the thickness for the shell. Okay. And yes, in the model, it doesn't have thickness for the shell yet. Okay. Alright, so we have 3 pieces of, technically 4 pieces of shell. Okay, we do have 2 pieces here, extruded from this edge. Okay, and for the connection bar, let's right click, edit, monkey wrench. Material will be steel, thickness 1/8. Okay, and for the handle and the T-shell, that's the same. Seems like we cannot do them, make this in one step. Okay, so steel thickness is 0.375. Click OK. Remember this from P shell 1, and let's go to the T shell, this T joint here. edit. So we can reuse physics shell one. So they are the same. This one is the same as uh, this jaw handle shell. So those two have the same material and the same thickness. That's why we can use the same property. Alright, so now we are done for the thickness of the shell and nylon, okay, pliers, or steel. So we only have this piece is nylon. All the others are steel, and they don't have material assigned right now. We have a faster way. Right click on the name or status, the same. You see this material view here. We can go to material view, and we have steel assigned, nylon, and we also have something that's no material. Okay, so in here you can actually find them like 1D collectors and those pieces we haven't assigned. Okay, so this is a way you can check if the material has been signed or not. We can go back to standard view, and apparently all the 3D collectors are steel. So edit physics solid 1 material steel. That's it. Then for the others, we can just pick solid 1. So that will save you some time here. Okay, I believe we have assigned a material to the shell. Let's go back to material view and turn off the nylon, turn off the steel. Okay, that's the stuff we don't have material. That's right. Yeah, let's see. Okay. Yep. And let's see what that is. That's the bar. Okay. So that looks pretty good. Let's go back to standard view, and okay, we have finished the stiffness coordinate system for bushings, and okay, we need to check the 2D mesh normal. So let's turn on this. Those two pieces, they're extruded from the edge of this piece, and remember Dr. Zarda talked about this gluing in class. You want to make sure their normal is pointing to the direction of the other face you're gonna glue this piece to. So let's check the 2D element normal. That'll be the top of your 2D mesh. We're gonna pick those two and display normal. See how this arrows, they're different. Okay, and remember this piece gonna glue to the top, towards the top. So you want to reverse this normal direction of the right piece. Let's deselect this one, display normal. You want to reverse this normal. Okay, now you want to pick those two, display. That's the right direction. Close. Okay, that's done. Next, we have done all the stuff in the sim, in the fam. So what we will do is, excuse me, save first. Save all. Okay. Now let's go to the sim. Window, sim. Okay. Now we are in the sim, and first we're gonna apply 2 glues and 2 contact. Okay. And if you remember, the jaw handle here is disconnected from the upper jaw right now. and that's why we need this first gluing for those two pieces. Alright, so we can expand the fem here, turn off whatever we don't need to see. We only need upper jaw and the handle. Sorry, jaw handle. And we can use this shaded. Alright, gluing is right here, surface to surface gluing. Okay, and you want to use manual gluing. As to the source and the target, that's the same, so it doesn't matter. He did mention that you want the source to be the finer mesh. However, we have the same size mesh. Doesn't matter here. So we will create a region for the source. And here you can name the region. And I'm gonna just leave this region 1. Or you can say the bottom of upper jaw, whatever. Select object. We can use some method here. Feature angle element face. Okay, so it'll pick up the element face that's within some tolerance of angle. That was quick. That's my middle mouse button. Okay, so again, let's have a look. Monkey wrench, that's the surface. If we want to see clearly, let's turn off this. So this will be the source region. Then let's create the target region. We can turn this off and pick this up. No method. If you click, that's just a one element. Feature angle element. You need to deselect this first, and using the same method, then go to feature angle element faces. I'll pick the whole face. Okay, target, source. Just use apply. Okay, so that's gluing for the first one, and since we clicked apply, we can keep going for the second gluing. Okay, and that will be the jaw handle to the 2D portion of your jaw handle. That's this T kind of T shell. Okay, so the source region, we're gonna use this bottom of this 3D portion. So let's turn off the 2D portion first, create a new region and pick this one. Okay, and for the target, create another region, turn off the 3D portion, turn on the 2D. Maybe you need to turn this on to give you a sense of direction, which side you need to pick. Okay, let's pick the top side. Alright, and here, surface for 2D element, the top is the same direction as your normal. That's why we switched the normal of half of this shell. Okay, and we can just click OK. See, that's the arrows from the target, that the longer arrows are from the source. Okay. Alright, now we have two gluing. Next will be the contact with friction. Okay. If you don't like it, we can turn this off, so it will be clear in the view. And let's do the contact. We need lower jaw and the 3D portion of the handle. Okay, so that's the contact between these two pieces. We can turn this off first, then 2D surface to surface contact. Again, that's gonna be manual. Source region, build a new region. Again, the same method. pick this one. Apparently this one is not good. Okay, we just need this flat surface. Okay, let's first shift and click deselect. Let's try what's better, related face, and turn on the polygon and pick up. No, it's not there. Alright, now we can use again feature angle element faces. We are gonna play with this arrow. We're gonna turn this tolerance to really small, let's say 5 degrees. Okay, and pick one element here. Alright, that looks good. That will be the region for the contact source, then the target. Turn this off, turn on the lower jaw. That will be this cylindrical face. Pick this one up. If seems like the angle is too small, but we can, try to pick more. Oops, don't need this. Yeah, make sure you only pick up the right portion, so we can use static wireframe and come back to shaded. Click OK, then just leave this friction to 0 and then click OK. Alright, here comes the arrows. Then turn this off. We can also turn this off to do the second contact. Okay, that's between the stopping block and the back of the jaw handle. Stopping block. Okay, and surface to surface contact, source region, the same method. Pick this one up. It stops here, that looks good. Click OK, then target will be this side of the stopping block, so you want to hide the jaw handle. Pick this one, that looks pretty good. Okay, and let's click OK. Alright. Okay, so we have the full surface to surface relationship to gluing to contact. Then we're gonna go back to our usual stuff, which is the force and the constraints, load and constraints to be exact. Okay, so we're gonna fix this whole structure at this point. Okay, and that will be a fixed constraint. I think I reversed the order. Okay, fixed constraint for the nylon bar. Okay, so you would probably think, okay, this one is fixed, and the others, the whole thing should be good. Turns out, if you fix this bar, consider this bar is an or axis. The whole pliers can rotate on this bar because the solid element doesn't have moment. It cannot carry moment. So that means if you cannot if you fix this C bar here, the limit on the rotation cannot be transferred into your solid element. So all the solid can actually still rotate. Anyway, that's why we need to apply another some other constraints on the stopping block, on the handle, and to the two handles. Those will stop this from rotating on the Z direction. So that's why we're gonna kill Z translation on those three position. So user defined constraint, and we're gonna kill z, translation degree of freedom 3. So let's do this first. For each spot, you want to pick at least 3 nodes, but that's not in line, so you don't want to pick this one. You want to pick this. Those 3 nodes it's like it will define a plane. Okay, you don't want 3 nodes in line. And to have better distribution, you can probably just pick more nodes. Okay, apply. That is for 1, and we can pick something here as well. Yeah, just pick some. Maybe that's way too much. Okay, we can hand pick some nodes. And degree of freedom 3, apply. Then for the last one will be on the stopping block. So turn this on, turn off the gluing and the contact, pick those nodes. Couple nodes would be enough. Kill degree of freedom 3 and OK. Alright, now the last step, force. We're gonna squeeze this handle using 10 pounds of force. So we're gonna apply force on this node as well as one node like somewhere here but in the middle of this 3D mesh. Excuse me. Alright, so load force. Then let's find this one first. You want this node 4809, and you should have the same ID because we gave you this mesh already. So you want to pick this one and 10 pound. The trick here is the vector. You want to use like you want to define the vector by 2 points. So you want this point, the vector to point from 4809 towards this node. So that will be in the opposite direction to make this force opposite and equal. Apply. So that's the first force. Then the second is still 10 pound, but from this point, and again the vector would be from this point to 4809. Okay, now they are equal and opposite. And if you like, you can actually make this force look bigger. Edit display, make it bigger. Alright, so we have the boundary conditions, we have force, we are good to go, hopefully. Alright, let's save all first. Then do a model setup check. See, there's one warning, no error. And let's go solve. And you want to turn on the SPC forces in the case control. So output request SPC force, go to print. Okay, and solve. Now it takes some time. That's why we use linear attachment. If we use parabolic, it's probably gonna be longer. And really depends on how fast your computer is. You can turn on your task manager, and it's killing my computer. So And I'm not sure if the recording is good. Alright, complete. And, but it's still writing. And do not turn off that window. Okay. This is much longer than the project we did last semester. Okay. Results, displacement. Alright, we got pretty much the same results as, not pretty much, we got the same results as what Doc Zada had. So let's have a look at the animation. Okay, looks pretty legit, and I hope you can get the results. And that's all for this lab. Thank you.